To start this problem off, we're going to write out the sum of three numbers is 852 as an equation. Let's go ahead and call the three numbers x, y, and z. So if we add all three of those together, we know we would get 852. The other piece of information we're given is that one of the numbers, x, is double the sum of the other two numbers. So we can write that out as an equation as x being equal to double, or 2 times, the sum of the other two numbers. Well, that would be y plus z. And we can write that without brackets. That would just be 2y plus 2z. Now, the next thing we're going to do is rewrite this original equation, but instead of x, I'm going to replace it with what we just figured out x is equal to, 2y plus 2z. So that would look like 2y plus 2z plus y plus z equals 852. And from there we can simplify that a little bit by combining our like terms. We would then get 3y plus 3z equals 852. Now, at this point, it might be a little confusing of where to go because we still have an equation with two unknown variables. So we can't really solve for one of them. However, if we use the elimination method here by multiplying this original equation, if we multiply everything by 3, we would then have 3y and 3z to match the 3y and 3z in this equation down below. And then using the elimination method, we could take one equation, subtract the other, and then we would have an equation with only one variable because we'd be eliminating both the y's and the z's. So let me show you what I mean. Multiplying everything here by 3, we would get 3x plus 3y plus 3z equals 2,556. And then what I'm going to do is I'm going to rewrite this equation just below it. So it would be 3y plus 3z equals 852. And now we're going to subtract. We're going to take that first equation, subtract this, and you can see that the y's and z's would cancel out, and we'll just be left with 3x equals 1,704. And of course, our last step to solve for x would be to just divide by 3, getting an x value of 568. So that is our x value. I hope that was helpful, and thanks for choosing JD's Prep.